You must have seen in many war films where the military is planning a sequence of action to take. Now this sequence of action is called tactics. It helps to plan before going to the war. But what does tactic mean in the context of machine learning? It can help deciding an approach to solve the machine learning problem and avoid directly jumping to algorithms. So in this video, I will demonstrate to you machine learning tactics by taking the Kaggle space Titanic problem. Now this video has got three parts. The first is the data exploration visuals to understand the problem. The second is the tactics to solve the problem. And the third is implementing these tactics with Python. The demo which I will be showing you is also available on the platform experienceddatascience.com. You can also access this demo and try it out for yourself. So my friends, let's get started, but do not forget to subscribe to the channel, like and comment on the video. The Kaggle space Titanic problem is one of the very popular machine learning problems based on a fictional story about a spaceship Titanic which collided with a space-time anomaly. Now, though the ship stayed intact, almost half of the passengers were transported to an alternate dimension. And the machine learning task is to predict which passengers survived and which did not. The data contains passenger details such as the home planet of the passenger, the destination planet, the cabin, the age of the passenger, and the amount which it paid for different services. Now, using this data, we have to predict the column transported. Now, let us see some data exploration visuals. Let us first start with the descriptive statistic for numerical columns. Now, here we see that age equal to 0, which means that for some of the passengers, the age has got missing values. Also, for all services, we see that 75 percentile is also 0. So, most of the people are not paying for all these services. Now, let's see the descriptive statistic for categorical columns. And here you can observe that there are many values in the passenger ID. So we can do some feature engineering so that the passenger ID can be used in a better way. Also, if we closely observe the data, we see that there is a link between the passenger ID and the names. For example, here we see two passengers who have the surname Sunset or Suscent. They also have similar passenger number before the underscore, which is 0003. So we can conclude that the value before the underscore indicates a passenger group which is traveling together, and the value after the underscore indicates a sequence of passengers within that group. So we can divide the passenger ID into two fields. One is before the underscore and one is after the underscore. We also observe that the categorical fields such as the home planet have a blank value. So this also indicates a missing value. Now let us also analyze the field cabin. And once again, like passenger ID, there are too many values. So probably we can also split the cabin into three parts based on the slash. Now let us also analyze the missing values. So here is a bar chart which indicates the number of missing values for the numerical columns. And we observe that all the numerical columns have got missing values. Now let us also see the missing values for categorical or non-numerical columns. And here we see that the passenger ID does not have a missing value, which is good news. So we can probably use this field to fill up other fields where there is missing value. Let us also now look at the correlation matrix for numerical fields. And here we see that there is not much correlation between all the different numerical fields. So this means that we cannot use the numerical field to fill missing values for other numerical fields. Shown here is a correlation between categorical fields, also called as a Kramer V. Now this visual is only for passengers who are traveling in a group. And one interesting observation we can make is that there is a correlation between the passenger group and the home planet. Now this means that the passengers in the same group were coming from the same home planet. We can also see that there is a correlation between the passenger group and the cabin, and this means that the passengers in the same group were also in the same cabin. So, as the passenger group does not have a missing value, we can use it to fill the home planet as well as the cabin fields. Now let us also look into an interesting heat map for passengers who are traveling solo. Here on the x-axis we have the home planet, and on the y-axis you have the cabin. And this heat map shows that most of the passengers in the cabin G were from the home planet Earth. So we can use this logic to fill the missing values in the home planet for the solo passengers. Let us also now see the outlier analysis, and we can here observe that there are few outliers which are shown in the blue color. So it will be useful to remove these outliers, and as this outlier seems isolated, we can use isolation forest algorithms to remove them. Now based on the data exploration, we can develop our tactics. Our tactic will start with feature engineering, then missing value replacement, followed by outlier removal. Then we can also train the model as well as score the test data. For feature engineering, we will start with replacing the blank with nan, which will help us better manage the missing value. Then we can split the passenger ID, as well as we can split the cabin, as well as we can also split the data based on the fact that if the passenger is traveling solo or in group. We will also need to standardize the numerical columns as well as encode the categorical fields. And then we can move to the missing value replacement. We will replace the home planet and the cabin based on the passenger group for those passengers who are traveling in a group. And for solo passengers, we can fill the home planet based on the cabin. We will then combine the group and the solo data. We will then apply the KNN algorithm to replace all the missing values. For the outlier removal, we will use isolation forest. For the model training, we will have to split the data into train and test, and then we will use the algorithm XGBoost. For scoring data, we will have to apply the same steps and then make the prediction. So as you can see that the tactic gives us a good idea of our execution plan. Now let me show you how to implement this tactic in Python using my demo platform experiencedatascience.com. Let me first start by going to the experience machine learning tactics. Now here you see multiple options. The demo story will explain you the solution with visuals and explanations. If you go to the demo, you will be able to generate all the data exploration visuals which I have shown you earlier without any coding. Let me also give you a very quick example. Now here you see the available data sets. So let me go ahead and select the space titanic data exploration data set, copy it and make it ready to use. Now once the data is copied, I can select it and do all the data exploration analytics. Now here you can display your data, you can make all the descriptive statistics, you can analyze the missing values, you can also make correlation metrics for both numerical as well as non-numerical data, as well as you can also make outlier analysis and the heat map. I will not go through all of them, but let me just explain you one analytic about descriptive statistic. So let us go ahead and select the descriptive statistic. So let me go ahead and select all the columns. You can always hover over the tick button to see on what to do at each step. Let's also get the descriptive statistic for numerical columns. Let me now execute this, and in a while I'll get my descriptive statistic which I have shown you earlier. So as a call to action, you can try out all these data exploration visuals. Now let us go back and we will implement the tactic with the Python code. So let me first start by going ahead and selecting the training data, copying it and making it ready to use. I can also do the same for the test data, which also we will use later. Okay, so the data sets are now ready. So let me go ahead and select the training data set and start the coding in Python. Now here you see two windows. On the left is the VS Code editor where we'll be writing all the Python code, and on the right hand side you will see all the output. Let us start by importing the packages. Now the editor is already linked with the data and the data is available in the data frame df. So let us first copy df to df underscore train. As we have seen that we have many categorical columns which have a blank value, let us replace all the blank values with np.nan. Now let us split the passenger ID into passenger group and the sequence based on the underscore. And as the passenger group and sequence are numeric, let me also convert the data into float. I will do the similar for cabin by splitting it based on the slash and then converting the cabin 1 into numeric, as the middle part of the cabin is a numerical value. Now let me also create a new field indicating if a passenger is solo or not. Basically we can calculate the number of passengers in a group, and if it is 1 then the passenger is solo, else not. Now we are ready to standardize the numerical data and encode the non-numerical data. So I will create a list of categorical columns and also a list for numerical columns. I can now create a column transformer which will apply a standard scalar to numerical columns and an ordinal encoder to the categorical columns. I will also store the output of the column transformer into a variable called as preprocessor. Now let me fit the preprocessor to the training data and store the output in a new data frame called as df underscore train 1. Now as we have seen in the tactic that we need to split the data into solo or group before the missing value replacement. So let us do that. I have two data frames, the df train solo and df train group. Now we can use the preprocessor which is already fitted to transform the data frame solo and group. Now we are all set for the missing value replacement, and let us start by creating a data frame which will have only the passenger group and the home planet for the passengers who are traveling in a group. I will use the KNN replacement algorithm to impute the missing values. Now in this algorithm we need to select the number of neighbors. Now as the passengers who are traveling in a group will have minimum one other passenger in the same group, I will select the nearest neighbor as 1. The result of the missing value replacement are stored in this array, and we will use it to fill the home planet in the data frame. We can apply the same logic to replace the missing values for cabin, and after this step we have the missing values for home planet and the cabin are replaced with the nearest passenger in that group. Now shown here is the missing value for home planet and the cabin for the group passengers before and after the replacement, and you can see that the missing values are now 0 for the home planet and the cabin. Now let us do the missing value replacement for the passengers who are traveling solo. And as we have seen earlier, we can replace the missing values in the home planet as Earth if the cabin is G. Now at this stage, all the values in our data frame are numerical values. So we can use the encoder to see that the home planet Earth corresponds to the value 0 and the cabin G corresponds to the value 6. So we can replace the home planet with the value of 0 wherever the cabin value is 6. Now let me combine the two data frames, Soro and group, into one data frame. And now we can also apply the KNN algorithm to replace the missing values in all the remaining columns. So after this step, all the missing values have been replaced, and shown here is the missing value before and after, and it is great to see that the number of missing values are now 0. As seen in the tactic, let us now also remove the outliers. And we can use the isolation forest algorithm. It takes an argument called as a contamination factor, which we can keep it as 0.005. The algorithm will mark all the records which are outliers as -1 and all the records which are not outliers as 1. So I can filter the results and only keep the records which are marked as 1. So after this step, we can see that the number of records in the training data has reduced. Now there are few less records which correspond to the fact that the outliers have been removed. Now my friends, we are ready for machine learning. So let us first start by splitting the data into train and test. I'm also going to create a machine learning pipeline with the gradient boosting algorithm. Run the training, make the predictions and calculate the accuracy as well as the confusion matrix. I get an accuracy of almost about 80%, and I can also store the confusion matrix as an output in the data frame df_out. I will also save the model and the preprocessor in a dictionary called model_out, and this dictionary is automatically saved in the platform, which we will use it later. Now if you want to reuse the code, just go to the top section called the code list, select this code which is marked as play code for model training and copy it. Now let us go to the model scoring for the test data. So let me go back and select the test data and start the coding. But first let me select the model which we have created in training. So if you go to the model list, you will see the models which are created, and let me select it and use it. Now let us start the coding. Now as most of the steps are similar to training, I will just copy the code which is available as the play code for model scoring. And the only difference is that here we are reading the preprocessor value and the model training pipeline value. We will do all the feature engineering steps as before. And for preprocessing, I will recover the standard scaler and the encoder from the preprocessor and just apply the transformation. And then I will apply the missing value replacement as I have shown you earlier. Now for model scoring, we do not need to remove the outliers, but for model scoring, we will just take the pipeline variable which has our trained model already stored and use it to make the prediction for the target column. Now the results are stored in the data frame df_out, and when I run this, I get my predictions as shown over here in this particular table. I can download this file and then submit it to Kaggle. I got a score of 80%, which got me in top 10% of the leaderboard. So I would recommend you to try it out. Try changing the parameters of XGBoost and see if you can get a higher score. So hopefully my friends, you have enjoyed this video. If yes, please comment, like and subscribe, and see you soon in another exciting video.